All right, welcome everyone. We're ready to start our webinar today. Welcome to Bayesian Lund. And this webinar is continuation of our series of webinars here at Bayesian Lund. We started in August with a talk by Paul Bruckner on BRMS, and then we looked a little bit into data visualization with Matthew Kay and various ways how output from Bayesian models can be visualized. And then last month, we had a privilege of hosting William, who presented stun targets and targets in general, targets workflow. So that WinLab now was very, very helpful in visualizing the workflow, how it's implemented in practice, and could be also automated using targets package. And today, Aki will present Bayesian workflow in his recent paper, how it's laid out and illustrated with examples and answer some questions. I think Aki doesn't need an introduction, but just for the sake of formality, Aki is a professor at Aalto University. He is a very prominent figure in the Bayesian domain, author of books, articles. I think he is very influential for all of us. We're very privileged to have him here today with us. Aki, the floor is yours. And just want to say that if you have questions, please type into questions and answers. The panelists here are monitoring. The panelists here are Ulrika and Rasmus, are my colleagues at Bayesian Lund. We're monitoring the Q&A, and Aki will seek questions as well and answer them when the time will allow. Thank you.
Okay. Thanks for the invitation and thanks for the introduction. And your previous talks by Paul, Matthew, William, they are very relevant and connected to what I also talk now. So this is partially based on preprints we have in arXiv with Andrew Gelman, Dan Simpson, Charles Margossian, Bob Carpenter, Yuli Yao, Lauren Kennedy, Jonah Capri, Paul Berkner, Martin Modrak, and we are in progress of extending this to much longer version. And I don't have time now to talk everything what is in this paper. I can't even get the main figure to fit in slides so that the font would be readable. So I can fit it, but then it's difficult to see the small text. And it's also good to think about that it's not just one Bayesian workflow. There are a lot of different workflows depending on the context and sub-workflows. And so you can think here in different parts. For example, here it says cross-validation. Even just for the cross-validation, we have its own workflow. And even there, we could also have arrow coming back. If something doesn't work, we can try something else. So there is a lot of complexity in all of this. But then in this talk, I want to talk more just about on a higher level, why thinking about the workflow is important and why different frameworks, documentation, and possible software, why it is important to develop them. So workflow frameworks, they can improve efficiency, reliability, reproducibility. I will talk a little bit about practical workflows. There can be shortcuts in workflows, and we can make comparisons to engineering. One important part of this workflow, specifically when doing model building, even if it's not Bayesian, but overall model building, it's iterative process, and I have a few points about that, comparing to software development as a learning process and as part of scientific science itself. I say something about this iterative model building, as there are some arguments against it and why it is okay to do iterative model building. And then in the end, more about where we are going in the future and more software assisted workflows. The workflow term itself, it's not new. The first reference I could find in a paper is from 1921 in Journal of Railway Engineering. And there, of course, it is also that when you are making a railway, it's good to have a workflow so that you would have good quality, reproducible process of laying out railway tracks. Now the workflow term has been getting much more popular since beginning of 1990s, and it seems that now writing the words together is more prominent. It seems we are possibly past the peak hype, although there might be again sudden increase of the use again. It's not yet so popular in as a Bayesian workflow. There were no mentions in Google Books before 2019 for the Bayesian workflow, but there are these terms: scientific workflow, data analysis workflow, although much less as a workflow overall. And from these, scientific workflow has been more popular. And this is something that in the beginning of 2000 started appearing these papers on scientific workflow systems. And specifically, like in bioinformatics, where collecting data, making repeatedly similar type of measurements that need to be then pre-processed in a different ways and so on. It was natural then to start to build workflow in software that does these things step by step, and we can avoid manual work, mistakes, errors, forgetting doing things. But these systems are still presented usually just going in one direction. Here also there is this term validation, but there's no explanation that what if the validation fails. There's been, like the bioinformatics was one of the first fields, but then it's been appearing in many other fields. Like here's a high energy X-ray microscopy. And again, dividing the task in subtasks, but then the flow is still just forward, and something that we can hopefully easily repeat. So these workflow frameworks and tools, they improve efficiency, since once you've set up some workflow, you can automate it and it's fast when you get the new measurements to repeat your workflow. It's more reliable, less possibility for human error, reproducibility, that the analysis is made every time in the same way, and it's easier to share for others. This is what we did. Here's our workflow framework, code for it, the files defining how it was done for the specific case, and others with their own measurements can follow the same workflow. Bayesian workflow term, it seems first time around 2016, Tim Spitz wrote a blog post, an introduction to Bayesian modeling Stan for economists, and they used the Bayesian workflow. I mentioned already that there's no just one Bayesian workflow, and I'll come back to this again during this talk. And then there was a first paper, Visualization in Bayesian Workflow, 2017, and then it's started to be more and more used. But this is not new thing in Bayesian modeling or modeling overall, these ideas. It's just that the workflow term is new. Very important person who's been advocating some of these ideas has been Box. The earliest paper from him, 1955, discussing this kind of iterative model building, gradually making the model more elaborate. And then his more famous paper, 1976, Science and Statistics, also having then the points of advancement of learning, iteration between theory and practice, and feedback loop, so that the model building is also that you get some data, facts, you make some model, and then you learn from the model, and then you decide to make another model. And so there's certain progress in time, what you learn, but on the other hand, there is also then the feedback loop, iterative system, how you are checking your model against the facts. And also simplified in that same paper, inference, criticism, looping, iterative loop there. These are steps quite commonly mentioned, also identification, fitting, diagnostic, checking, and then possibly going back, which was also part of Bayesian Data Analysis first edition. So setting up full probability model, conditioning observed data, so inference, evaluating the fit, and then possibly alter or expand the model and repeat the 3 steps. So again, the same loop. So the basic idea of this iterative building is the same. Of course, there's been now advances in having more diagnostics, different diagnostics. So adding more subflows. So this is from Sandhal's StanCon 2018 intro. The same things, scope out your problem, specify likelihood priors. There's recently been more emphasis on check the model with fake data. More emphasis also in check the inference diagnostics. But then we have again, model checking. And then, although this slide doesn't have the arrow back, we could then go and improve the model. And then in our archive paper, we have then added more details in this kind of workflow graph. It's still kind of high level graph that you could always in each submodule make that submodel specific sub workflow. And there are also different cases that sometimes in easy problems, we can go straight away the short path and no need for iteration. And this can be sometimes repeatable. It can be made easily software assisted. And in some cases, there would be only very rare that then we would need to suddenly go to computation is not valid and start to think different things. There's a connection to software development processes. Even if we would know beforehand what model we want to eventually build, even if the inference would work perfectly, even if the final model would be perfect, we need to write these models for computers, for example, using probabilistic programming languages. And then there's good to look at the ideas from the software development processes. And this is the classic Boehm's spiral model, which is used as a basis for many other more refined approaches. So we can start with some prototype, and then we can do different checks, come up with the next prototype, loop around next prototype, and eventually we arrive to something that we think that it's ready for operation, and then we do more careful checks before actually using it in operation. There's the example of birthdays. So number of births in US from 1968 to 1988. And here the plot shows the relative, so 100% and then relative to that. And here also, as a software process, it was easier first to make just model for this part, which was just a slow trend. So it was easy to start with something simple, and when that model works, then add yearly variation. When that works, add weekday effects, and then also add that these weekday effects are actually getting stronger in time, and then add special day effects. And then also now in the end, if this would be something useful for production, in the end it would be sensible to make even stricter validations for the whole. Also, it's good to think that there's not just one workflow. In engineering, we can also start building prototypes, and they can be taped together, don't look so nice, and so on, as long as we can get these proof of concepts that this looks like it's working. And then for the final model, make more rigor tests. So in a birthday example, for the simplest model, I could use just optimization instead of integration. When going to more elaborate models, I was using just very short Markov chains. So short that it's not completely certain that like whether it's converged or do we have enough draws for reporting certain estimates with like 2-digit accuracy and so on. But even these optimization and short chains were able to show that first, my code is actually working, and the results look somewhat reasonable. So it is sensible to go forward. But of course, then if this would be used for something important, I would then run in the end much more rigorous, longer MCMC chains and more complete convergence diagnostics and so on. We can compare also like that there are different requirements in different types of model building, and compared to cooking, we can make a sandwich out of available ingredients corresponding to some generic model that is useful for almost any data. Like normal linear model, it's not probably the best dish given the ingredients, one can be delicious anyway. For example, in Regression and Other Stories book, we have example of looking at the height of people is related to their earnings. And we can see first just fit normal linear model. It's fast to fit, and it will show that yes, there's connection that taller people earn more. That model is not perfect. It's predicting also for some people negative earnings, or at least giving some probability that some people might earn negative amount of money. But then changing to that, for example, using it in log scale or using log normal model, it doesn't change our conclusions. So sometimes we want to have just a quick snack, and it's fine to use these generic tools. And then in those cases, workflow is a bit different. Maybe you have a recipes to make a dish with pre-listed ingredients, and when your data collection matches these pre-described models, like in ART and ARM, BRMS, even Shiny BRMS with just point and click, a bit of typing in some text entries or numerical entries, you can manage to a lot of useful models, and these are simple. But these assume that you really have already these certain ingredients, and then if it happens that you don't have some ingredient available, or you have something else, they are not necessarily telling you how to proceed, or they might give you the dish that it's a complete failure, because like in making cakes, you can't make a good base of cake if you improvise too much. So these are, so the workflow can be simple if your data collection and collected data matches some pre-test models. And then the workflow gets more and more complicated, that if you need to do a really elaborate model, you want to make a recipe to be used in fine dining restaurant, and so this may require several iterations. And this would correspond to writing your model in probabilistic programming language, having the secret ingredient, secret sauce there to make it really sign your model for that specific data you have. All of these are also such that the workflow changes completely depending whether you are making the dish for one person or whether you need to make it to 1,000 people in one day. So scaling changes also things. So then the previous parts were still kind of a lot of about these processes that you want to go towards some end goal. But here I want to also emphasize that that these iterative workflows are useful not just getting somewhere, but also as a learning process. And this is what Box also taught about. And incremental learning reduces cognitive load. We don't teach Bayesian statistics in school in first grade. They need to first learn numbers and summing numbers and so on. So it's easier to start from simple things and then later more complex things like Bayesian inference can be built on top of that. In the same way, when you have complex data, it's possible then that if you start with something which is too complex, maybe you get good fit, good predictive performance, but then you don't know what are all the parts in the model doing. And especially if you are working with the new type of data, new type of models, it can be helpful to build also your own understanding about the models incrementally. Here's an example of golf putting made by Andrew Gellman. So there's distance from hole in feet, probability of success, bit small font, but it's mentioning there also how many puts did go in and how many puts there were from that distance. We could just do simply logistic regression, but it doesn't look that good. And then building a more elaborate model step by step. First, starting from that the ball has certain size, hole has certain size. There's some accuracy in the angle. So humans are not perfect in hitting the ball, and that's why there's a variation in angle. And further you hit the ball, more likely it is then to go past the hole. So more difficult it is to hit. And so just modeling the accuracy of the angle, we get this geometry-based model, which gets us much better fit than the logistic regression. Now it's easier than to make first this model and understand this component, and also now we see that this is already explaining quite a lot. There was more data, so the red dots, so that there's also longer distances, and this angle-based model was not that good for the longer distances. And so now adding also the force, how strongly the ball is hit, that affects variation where it's ending. So we assume that the player is trying to use such force that without hole, it would stop somewhere here. But if the hole is there, it will drop there. And then there's some variation. But if they accidentally hit too hard, then the force which would take a ball normally without hole here, it means also that if the hole is there, it just jumps over. And this will improve the fit. But now it is possible to see these effects differently, and it's possible to learn more about the phenomenon and what is important for this. And even this is quite simple. It's not yet taken into account what was the weather, what was the grass condition, what was the green, whether if there was a slope or something like that. We can think also models as experiments. So we make some model, and the model can help us to see better something interesting in the data. And then though that interesting thing can lead to what would be the next model. It's possible that we, in the beginning, did not see this. In the birthday example, having already the model with smooth trend, this yearly trend, weekday effect, special day effect, or day of the year effect, actually. But it is clarifying, showing, for example, that there's less births on Independence Day. But now that when we plot this, we also see that there's bumps on the left and right. So just before and just after Independence Day, there are more births. And then when seeing this, then it starts to like, oh yeah, if the babies are not born on Independence Day, they have to be born on some other day. And that maybe we should actually use that kind of model that on average, we take into account that the babies need to burn on some day. And for these special days, we need to spread them, some kind of ringing effect. And this kind of things have happened often when I've been working with domain experts in modeling, that they first describe the data, the problem, we come up with some model, I make the model, I present the results and say that, look, there's something strange happening here, I don't understand this. And then they right away said, oh yeah, this is because the data was collected like this. And it was something that they didn't remember beforehand. But it ends up that I'm using models to interrogate the data to get questions that I can ask the domain experts to answer, and then together we can make more elaborate models. And when we compare these, that when we think about the workflow just as a development process to coming to some specific end model, we probably only store only the end, that final model, and present only that one. But when we are taking these models as experiments, we may want to also store series of models, and we may want to report results also from simpler experiments, just because they are also easier to communicate. They are easier to compare to facts, easier to validate, and so on. And it might be that then part of the workflow is also thinking how to present results from many models. Cost and benefit of model building. If I draw something like this, it's a model. And I'm quite certain that you recognize that it's a model for human. It's very simple. And sometimes this model is sufficient. It is conveying the correct message. So it's useful to think, what is the purpose of the model? Do we need more details? The same way is we don't need relativity theory except in high gravity, high speeds. So Newton's mechanic, although it's wrong, it's often sufficient. Stick figures are often sufficient. We can also then improve the complexity, add more joints, add more shape. Now it also looks possibly female, and we can add more details. But we don't always need to go to these very super detailed to be able to already infer that interesting thing from the data. So we can think that there's the cost and then benefit. And it's usual that we have something like this. And this cost, it can be the time spent building different models, or cost of inference, cost of interpretation of the model, and so on. Instead of right away building this most complex model with high cost, it might be useful to start building first few of these models. And if it happens that the curve is actually like this, instead of building this model, if we first build this and this, we might already see that the improvement here is so small that maybe we don't go further. So we get reduced cost. And sometimes we might be happy already with this, even if we know that maybe adding more components would give more accuracy. Sometimes this can be sufficient. We can think that when the workflow is as a software development process, we had already in the mind what is the final thing, and it was just about the implementation issue. But when we are thinking more about this as a learning process, and more about this doing model checking and then improving the model and so on, some people say that now you are violating likelihood principle. You are using the data more than once, since you first decided some model and prior and fitted the model to the data. Then you looked that, oh, the predictions are nonsense, and then built another model. You used something extra information. Also, if we are comparing different models, if we are doing just inference conditionally on the selected model, we are violating these principles. But we don't need to necessarily kind of stop because of that. One thing is that we can also always, when we have many models, integrate over the model space. We can think that this path towards complex models was something that we were likely to do anyway, and we just take care that different possible branches where we might have ended up are taken into account in the integration. We will learn also then how likely different models would have been, and take into account uncertainty. So not just selecting, but taking into account the uncertainty between the models. There is also ways to do proper decision theoretical inference of the model selection. Missing perfect calibration is not the problem. We don't need to have perfect frequency properties. Even when we build just one model, it's unlikely that our model and prior would be matching exactly the nature. And then if they are not exactly matching, we don't have perfect calibration. So if we get a slight additional miscalibration because of checking whether our model is sensible and improving the model, it's not harmful. Of course, we need to be careful that we are not overfitting and not tuning too much. And we have diagnostics for this, not to tune too much. And I do discuss many of these things in these other talks. So 1.5 hours, so I don't have time to go more in deep at this time, but the links are available. These slides will be made available Then we can write these Bayesian workflow papers, PDFs, we can write blog posts, but I don't think that's enough. If we make checklists, people would need to find these different PDFs and blog posts and follow checklists, but it's there's a still possibility that you miss something, and there's the kind of the responsibility for the user to check that what they've done. And so we want to have more computer-assisted workflow. We already have something. It is already useful that we have these kind of code generation and model libraries like BRMS, Bambi, that you will make less mistakes in building your models. Computational graphs, targets was mentioned in the beginning, and the other this scientific workflow software that can help that when you have certain repeatable tasks, that you can set them up, for example, in targets, and then repeat that. But these are not yet answering what to do with this complex workflow where you might need to go in different directions with new data, new type of models, and you might need to do more of these iterative model building and learning. These are not yet suitable or targeted for those things. We have a lot of diagnostics in different packages, and then these are have some kind of integrations also with common probabilistic programming frameworks. They could have more. They could have more informative messages that what to do when you see certain diagnostic messages. They could have more of pointing towards what you need to learn in this case. It's not always that there would be easy solutions. Sometimes you really need to learn some new thing. So we can more easily automate sub-workflows. So it's easier to start from bottom, and then eventually when we have different sub-workflows more automated, start to build this higher level workflow. We want to allow shortcuts also with automated diagnostics. One example would be default priors. So when people are using Stan and ArviZ BRMS, they are often using the default priors. The more strict workflow says that you should do prior predictive checking. But there are cases where you can, your data is, and modeling task is easy, and most of the time the default priors are just fine and the data is informative. But if we have these automated diagnostics telling that actually now you need to think about more about your priors, that will help. That will help time that you don't do stupid things when your prior information is or data is not informative enough and you need to think about your priors, but you will save other times a lot of time. We need to have more interplay between software, diagnostics, documentation, and we need to have these at different levels of detail. We can't, when we get some diagnostic, MCMC diagnostic warning, we can't immediately just print out a whole book about Markov chain Monte Carlo and measure theory and so on. So we need to have short message there, but we need to also have, if necessary, pointers where to learn more, and at different levels. So bit more, and eventually it is possible that to understand why your inference is breaking, you need to even learn a bit of measure theory. So it would be nice to have just-in-time learning, so that these diagnostics, so that you could more quickly start doing at least some kind of modeling. And when it works, fine. But when you get diagnostic warning, you will get the information what you need to learn at this time. There's also Bob Carpenter has nice slides. What do we need from a PPL to support Bayesian workflow? Related to this, how to make things easier. Overall, when developing these workflows, so there's not just one Bayesian workflow. So different people can be recommending different things, which depend on the context, on what kind of models they are considering. If you are a method developer, consider creating different levels of documentation. So don't just write that scientific article. Consider also writing something that's easier to digest for users. So if you or someone else implements your new diagnostic methods, think about these different levels of messages you could provide that could be added to software packages. When you develop models, if you happen to encounter a case where you have a messy workflow, maybe document it also. Share with others that it's not always straightforward, just going from here to here, that you actually had many iterations there before you arrived here. Maybe for your paper, you will report just the one model, but maybe you can have additional material discussing a bit of these things, that why something you thought first didn't work, and what was your thought process then solving that. Contribute to the collaborate project, because this Bayesian workflow, it is big thing. We need to integrate many things. It's great if you can join projects which are already used a lot with a lot of developers, and then you can also help these more integrative, more high-level Bayesian workflows to exist. And here's just a reminder what I did talk, but I end now. Now I can answer questions.
Brilliant. Thank you, Aki. There are a couple of questions in the Q&A. Do you see the panel? Do you want to?
Yeah, I see this. So there was one, the slides. I'll make the slides available, and then
I think there's one question that is now in
I'm
answer.
just reading. I'm reading Thomas's question.
Sure.
Yeah, I said that there are not just one workflow, there are different workflows. And then so there was the pros and cons of iterative modeling, which seems to integrate both exploratory and confirmatory modeling into one workflow. And then question related to how this fits demands of pre-registration and the reduction of researchers' degrees of freedom. And so there's not just one workflow, and there are cases where it is useful to pre-register and use certain type of workflow. These are the cases where we are assuming that it's something repeatable, so that you know beforehand that what your data is going to likely to be, and you want to use some routine analysis. Then it's possible even to make like the bioinformatics workflow I did so in the beginning. It's possible to use that kind of, and like the tools like targets is great for them to make. I know at least TJ Marr has been using targets to make reproducible framework for if in the end he notices that there's something wrong with the data sets, and he corrects that, and then his workflow is automatically repeated to get the answer. But then even if you have pre-registered, if during your analysis you notice that actually that pre-registered model is complete crap for the data you collected, and you are able to see that there would be some other model that would be useful, then it would be better to, of course, go to that other model and say that, okay, we did not foresee in our pre-registration that this would happen, and you can learn more. But they are not just one workflow. So sometimes you want to use this just a linear, easy, predetermined workflow. Sometimes even there you might then to go a different track, but admit that now, okay, we went beyond the pre-registration. And sometimes you start from the beginning that you don't know yet what kind of model should be used for this new phenomenon. Okay, Jung Hong asked the same thing, conflict between the logic of Bayesian workflow and logic of pre-registration. I think I did answer that too. Fabian is asking that it's unlikely that STEM journals would publish this whole process of model building. And I agree. And I also think that it is reasonable to have also different levels of reporting, that you don't want to always report everything you did. Sometimes it can be useful that you have something like online appendix that reports more your results, but even then it might be that you are still reporting some intermediate results and don't discuss all the messiness. And I did mention then that the specifically messy cases, it's more of sharing these stories and experiences that people could learn, and it's then it's not just supporting that final paper you made, it's then supporting overall the community, that community can learn more about how to solve different kind of cases, see different thought processes. Alex asked that workflows involve passing data from one stage to the next. Are there standard well-defined data types? This is a great question. I did not talk about kind of data handling, processing, storing, but there are cases where it is very useful that there would be these standards. Like medical health records are messy, unstructured, and I'm certain that there are people who are thinking about this more than I've been thinking. But then also I think that there hasn't been much work in, or I know that there's been work on in machine learning side. I know that there are companies that are providing machine learning model databases, so that machine learners often also make many different types of models, and how you then store them and access them easily. So similar type of frameworks could be used also when we are making many models to store different models and different posterior approximations, like MCMC draws or distributional approximations, variational approximations, and they could also have that you could have also for the same model store different accuracy of these posteriors. All these can get complex, but are likely that there will be more support in the future. There's Wow asking, could you expand a little on the using data twice problem? In my field, it sometimes happens that the model changes quite a bit after seeing the data and calculating summary statistics from it. And this is usually done through the priors. Any guidance on where to stop? It's right now, like the first recommendation is to report also the first model and report how did the summary statistics or how did the inference change when the model was changed. That would add more transparency to the process. It is possible to use prior sensitivity measures. It is possible to use also these, like, integrate over the different models or look with the model selection that and these different other diagnostics, which is more reasonable model. But there's no so I don't have currently a paper that I would immediately say that look at this, how to do this. We are working on something like that that probably would help also in this case. So currently I can give this only this in more guidance in general terms. Anonymous attendee asks, are there community resources you would recommend for sharing modeling workflows? That's a good question. So the Stan website has Stan case studies. So for those who are using Stan, you could share your modeling workflows there and have them accessible. But then I don't know if, for example, PyMC has kind of central place where they would be storing case studies. It is a bit of issue that there are a lot of useful blog posts or case studies for the workflow, illustrating workflow for different models, but they are scattered. And so maybe I should start collecting some kind of list of workflow examples I like, and where others could recommend workflow examples to be added they like.
I think the Stan discussion forum is a very good place to start. It has a lot of people that would be sympathetic to the and supportive of this idea.
Yeah.
Sorry to interrupt you, Aki. I can't ask questions in the question answer window, so I'm sending them to you directly. But my question is about if you consider the coming up with the priors as part of the Bayesian workflow. You mentioned default priors, but could also more sophisticated methods to elicit judgment from experts and so on be part of the construction of priors, whether one would sort of construct them based on judgments on parameters or observables or something else? And is that something?
Yeah. Prior elicitation is often very important part. And then and again, of course, it varies from the case to case that whether it's something quite weakly informative priors that are needed, and when it is something that we need some more clever approaches for eliciting that information from domain experts. And there have been a lot of written about prior elicitation and these frameworks approaches. There are many software tools. I think one thing is that would be useful to have also is to combine it with more with these diagnostics to also inform when prior elicitation would be more useful. Because again, if you do the prior elicitation from the domain experts, if you do it carefully, it is time consuming and takes resources. So you don't want to make it in cases where it doesn't change the end result anyway. So then there can be also these methods that you can check how much additional prior information could help. Would it change? And if it would change, then you would want to ask more from the domain experts. And then, of course, after eliciting that prior information, you would want to check also, is the new result then sensitive to what was elicited? That do you need to possibly consider whether that elicitation process did really work, or do you need to check that also more carefully? So did this answer your question?
My second question was that you mentioned in the beginning that whether there is a conflict between the prior and the data, you would consider using another model. And can you elaborate a bit on that?
If I think I mentioned more of that, just like if the model predictions don't look at all similar to data, then that's indication that that's bad model. If there is specifically prior data conflict, that prior and likelihood would be pulling the posterior in different directions, that is also indication often that there might be something wrong. but of course, there are also possibilities that sometimes it just happens that you are seeing something exceptional. I think that overall, this use of informative priors is getting more accepted, partially because there's more and more prior information also available, for example, on different medical experiments, that what is the distribution of the effect sizes. So there is a really historical data available that can be used as priors, which and this kind of information, if it's available on internet, you don't even need to have that prior elicitation process. Of course, you still need to understand what is available and how would you use that as a prior information, and how similar your new case is to the previous ones.
There's one question that just popped up into the chat. Should one also take into account the decision-making criteria, such as expected value of perfect information, along with prior elicitation?
Yeah, so I think often it would be useful that you would take into account that how you are going to use that model. So one possibility when eliciting prior information is you just ask the domain experts to tell everything they know. But then if you also know that what is the goal with your model, you might be able to focus in that information, that you don't need to ask everything, but you focus that these questions are important now for what you want to get out of the modeling process. And then that would be related to also this expected value of perfect information.
All right. Thank you very much. I think there was a question at the very beginning. Shravan asked, address the extreme complexity of Bayesian workflow, but I suspect that you already commented on it, that it can be broken down into smaller pieces. But if you want to address Shravan's questions.
Yeah, so yeah, I think that currently, like what we have in different papers and blog posts and so on, we have examples of quite simple workflows and some hints about the complexity. But we don't yet have good tools handling more complex cases. And of course, we are far away of covering even 90% of cases. And
if there are any more questions, yeah, thank you.
I think that, so I'm hoping that many people would contribute on developing then these Bayesian workflow ideas. That it's not something that just a small group of people could solve quickly.
Yeah, and we all can improve and learn from each other. So it's a community effort.
Mm-hmm.
All right, if there are any more questions, feel free to ask them now. Otherwise, we're getting ready to thank Aki for today's presentation. This was brilliant. Thank you very much. I also want to encourage you to stay tuned for more updates. We hope to get this presentation recorded and put on the YouTube channel, but there are more events like this happening at Bayesian Lund, and we thank Aki and everyone who participated today for today's webinar. Thank you very much. I think we're going to close the meeting now. Aki, much respect and thank you so much for participating today.
And thanks for all asking these questions.
Yeah, thank you everyone. All right, have a good evening. Bye-bye.